Alright, so welcome to another segment of calculus as we now continue with integration. So integration is simply the process of anti-differentiation. In other words, it's the reverse process. Remember in the previous video we were differentiating, but the opposite of now going back to the actual expression that we had, and that is what we simply call as being integration. So in simple terms, we can put up a few general concepts. We can simply say if, for example, dy over dx is maybe a, x raised to the power n, how do you go back to the actual expression that you had, the expression of the function of y? So what you simply do, you simply, increase the index, the power by 1, then you divide the whole of this expression by the new power. What's the new power? The new power is simply n plus 1. So you divide by n plus 1. Now this is only true as long as the value of n is not equal to, to -1, because that will give you a 0 and that will defeat, the purpose. So that is what we mean when it comes to, to what we are calling as being, integration. For example, maybe let's say, we can simply give you and tell you to say, integrate, WRT. That means with respect to, x. So let's say integrate with respect to x. Maybe you have x to the power 3. Let me say b, you have 2x to the power 2. Then let me say you have got maybe 4x. And let me say that you have maybe d just a 7. Then e, we can say 3 over x raised to the power 2. And I tell you to say you simply integrate. I'll highlight some more concept, you'll be able, to see that in just a short while. Now, for the first one there, remember what you do is that the solution then would actually mean, for that one, it would simply, when they tell us to integrate, what we did say is that for x to the power 3, you increase the power by 1. That's what we mean, that's the concept. Then you divide the whole expression by the new power. What's the new power? It is 3 plus 1. So this is going to be x to the power 4 divided by 4. So it simply means you have actually, integrated that. So that is what we mean there. And let's move on to b. So that is going to be 2x raised to the power 2. So what do I need to do? I say plus 1, you add to the index plus 1, then you divide by the new power, which is 2 plus 1. So that will give me 2x raised to the power 3 divided by 3. So that is what we mean. So that is going to be the expression that, we are going to have. What about the c part? It says 4x. Remember already there, it simply means you have a 1. So you are going to say 1 plus 1. So you divide by the new power, which is a 2. So it will be 4x raised to the power 2 divided by 2. Remember, 2 can go into 4. 2 into 4 is 2x raised to the power 2. So that is what we mean there. Now suppose you just have a number and they tell you to integrate. How is that going to be like in the d part? Well, if you just have a number and they tell you to integrate, for example, you have 7, that 7 means that you had x to the power 0. Remember we said any number raised to the power 0 is equal to 1. So meaning that 7 can also be written as 7x raised to the power 0, because what we know is that if at all any number is raised to 0, then that gives you what? That actually gives you a 1. So therefore, how do we know the integration of that one? Well, it has a 0 there. It is the same as saying, x raised to 0 plus 1, then you divide by the new power 0 plus 1. So that will give you 7x to the power 1, but you cannot just write this plus that is simply, a 1. So if that 1 into 7 is 7x. So in simple terms, when you just have a number, just give it a letter. For example, if they tell you to say integrate 3, and to integrate 3 to just be 3x. If they tell you integrate 4, that will just be 4x. So just if you have a number and they tell you to integrate, just give it a letter. So that's the idea that you need to remember. Okay, what about in terms of what we are calling the e part there? So if I look at the e part, it says 3 over x raised to the power 2. Now remember, you can write this one by using what we said. If you have 1 over x raised to the power 2, that one drops the reciprocal, it will be x minus 2. When that one drops, the index becomes a negative. So in a similar way, when I drop that 3, it simply means that uh, x will be raised to a minus 2. So when you reduce it in that way, you can now actually, apply the rule that we are talking about. What's the rule? Remember, we said you simply increase the power by 1. So you add 1 and divide by the new power, which is negative 2 plus 1. So what will that give us? It will be 3x. Negative 2 plus 1 will give us a negative 1 over negative 2 plus 1 is a negative 1. So when I look at this one, it will be a negative 3x minus 1. Now, because that is a minus 1, it simply means that we can actually write this. I can remove that negative. The 3 will go on top. It will be negative 3 over x. So that is the way it is actually going to remain. Now, it's important. I was just giving you some few concepts that you need to remember when they tell you to integrate, but you need to remember that we don't just end there. There's another important concept that you need to look at. There's what we simply call as being an arbitrary. You can call it as being an arbitrary constant. And when we have an arbitrary constant, you are going to have what we simply call as being an indefinite. So we call it as being an indefinite integral. So when you add an arbitrary constant, we are going to be using C for an arbitrary constant. So that will give you what we are calling as being an indefinite integral. So that is what we mean. Now, of course, how do we go about that one? Well, you can put up an arbitrary constant because we don't know. Let's take, for example, that, we do have, let's take, for example, that we did have maybe an expression, y is equal to x squared minus 3x plus c, where c is a constant. If I was to find dy over dx in our previous discussion, it will be 2 times 1 will give me 2, then that reduces by 1 according to integration. Then if you have a number and a letter, you just remain with the letter. That's what we are going to have. Now imagine I told you to say, can you get back to that one there? Would it be possible for you to get back? Yes, if I told you to say integrate that one, we'd have said 2x, here there's a 1, but you say plus 1 divided by the new power 1 plus 1, which is a 2. Plus, if you just have a number there, we told you, you just add a letter. That's all. That's what you do. So it would be 2 cancel. It would be x squared minus 3x. Have you seen that, we have not accounted for the constant? And that is why in our discussion, when you are integrating, you need to remember the arbitrary constant, especially if you have not been given the upper and the lower limits, if you haven't been given the limits. I'll talk about that in a short while. So just to remind you, so far we have said, when you are integrating, under integration, you simply increase the index or the power. So you increase the index, you increase the index by 1 and then divide by the new index or the new power. That's what you do. So you decrease the index by 1, you reduce it by 1 and divide by the new index. So that is the concept. But remember, you need to be including the arbitrary constant. Very important. So include. So let's take, for example, I told you to say, integrate. I told you to say integrate 2x raised to the power 3 minus 3x plus 1. How can you do that? Well, if I told you to integrate that one, it simply means that you can simply say 2x to the power 3 plus 1 divided by the new power, which is a 4 minus 3. Remember that there's a 1 plus 1. The new power there is a 2. If you just have a number, give it a letter. So because that is just 1, it will just become x. Please don't write 1x, that is wrong, just x, but you put up a c there. So if you look at this 1, 2 there, 1, 2 there, 2, so it will be x to the power 4 over 2 minus 3 over 2 x to the power 2 plus x plus c. So this c is what we simply call as being the arbitrary. So this is what we simply call as being the arbitrary constant. So you should always include it when you are integrating. Very important. When you leave it, that expression is actually going to be wrong. So make sure that you actually include it when each time you are integrating. So very important. So as a rule that I may give you a good notation, so we can say, I don't want to erase that. So so far we have looked at integration. I've not looked at the symbol. So the symbol for integration, so the symbol for integration that you use looks like this. I love to call it like enconto in our local language, but of course that's the symbol that we use. For example, when we write, we write as 4x. What does this mean? What does this mean when I write it like that? Well, when I write it like that, it simply means that the integrand, so we can say means the integrand. So the integrand of 4x is to be integrated with respect to x. So that simply means the integrand of 4x is to be integrated with respect to 4x. So that's why you write it like that, dx, or you put up a dx because it's changing in terms of x, so you write dx. If there was y, you would put up y. If there was z, you put up z as well. So that is what you need to remember when it comes to that. Now, just a few concepts that I want you to understand when it comes to what I've actually put there. You need to remember that the expression, when you write it like this is simply called as being we can simply call it as being the integrand. Yeah, so you can simply call it as being the integrand. That is what we call it. But when the answer you get, the result can be called the integral. But when you add that constant plus c, then we can refer to it as being the definite integral. So that is the whole idea. So in general, we can say, maybe I can simply say in general, if you have your dy over dx is represented by the function f of x, then for you to get back to know the y, you need to find the integral of f of x, but remember with respect to x, so that's why dx, but you need to put up that arbitrary constant. So the moment you put up your arbitrary constant, the answer that you get is now what we simply call as being the indefinite integral. So that is what you need to remember. Okay, a few concepts so that we actually guide you again on what you need to do. For example, if I tell you, let's put up some further examples there. Suppose I tell you to say find a x to the power 5 with respect to x. B, I tell you dx, then c, I tell you maybe 2t raised to the power 3. Remember, because we're using t, so it will be dt. So it depends with the letter that you are using. Let's put up there and simply say maybe s squared minus 2s plus 3. That's the function that we have with respect, because I'm using s, so it will be ds. So you are making an integration with respect to dx. Okay, so this is when the integrand is actually a polynomial. Remember what I told you? So if I look at that, the solution, let's quickly look at that. X raised to the power 5 dx. Remember I told you this inside is what we call as being the integrand. Yeah, what you get after the result is called the integral. But if you add your c, that's the definite integral. So that is what you need to remember in our discussion that we're having. So let's work out this one. So right away, when you start integrating, you remove the integration symbol. So it's 5 plus 1 over the new power 5 plus 1. But remember, don't forget to add what we are calling as being the arbitrary constant. So that would be x to the power 6 over 6 plus c. So that is the expression that you're going to have. So that's the correct way if they have not given you the upper limit when you're integrating. All right. What about B part there? It says integrate dx. You can see there's no number, but what do you know? There's a 1 there. So it's like there's a 1 that you're going to have. It's like there's a 1. So when you integrate a 1 there, it's like you have, let me show you. It's like, I know of course that this is the same as 1 dx. But what do we remember? Any number raised to the power 0 is 1. So it's like there's x to the power 0 with respect to x. So how do you do that? It will be x, it will be 0 plus 1 divided by the new power, which is 1 plus c. So this is going to give you x, plus c. Remember, if you have, you seems like you don't have a number, just give it a letter. It simply means there's a 1 there. That's what we mean. All right. Okay, what about, c there? What does that mean? Integrate 2t raised to the power 3 with respect to dt. So what you do, please, the moment you start adding plus 1, eliminate the symbol. Plus 1 over the new power 3 plus 1, which is a 4, plus the arbitrary constant. So you can notice there it will be 2t raised to the power 4 divided by 4 plus c. If I look at this one, 2 there, 1, 2 there is a 2. So it will be t to the power 4 over 2 plus c. So that is the indefinite integral that we have in there. Right, like I said, the constant must always be added to the integral. And such an integral that you're going to have is simply called the indefinite integral. So those are concepts that you people need to remember. Okay, suppose you are integrating a polynomial, like in the D part. Suppose you are integrating a polynomial. Well, when you're integrating a polynomial, s raised to the power 2 minus 2s plus 3 with respect to ds. So you integrate individually. That's what you do. So there, it will be s, it will be 2 plus 1. You divide by the new power, which is a 3, minus there, it is 2s. Already s has a 1, so 1 again plus 1 divide by the new power, which is a 2. When you just have a number, I told you just give it the letter. What letter are they using? S. That's why it will be 3x plus c. That's what we are going to have. So it will be s raised to the power 3 divided by 3 minus, remember this 2 and that 2 cancel, so it will be s raised to the power 2 plus, there it will be 3s plus c. So that is what you have. That's the definite integral that you are going to have. Right, so basically that is the idea that you need to remember. So there's nothing complicated under integration. It is just the same concept that we are going to be using. So you need to remember this concept as we integrate. So when you're integrating, you add plus 1 to the index and divide everything by the new index that you have. That's the idea that we are going to be using. Well, let's look at some ECZ questions that have come before. I've looked at more than enough examples. So let's look at some of the questions in your paper 1 that have come in the ECZ exam there. So let's look at the solution to this question. So they told you to say find, you have seen, the integral. So they want you to integrate that one, 3x squared plus 8x minus 5 with respect to x. So this is a polynomial, so integrate separately. Then you put the sum together. So it will be 3x. Well, the moment you start adding plus 1 to that power, to the index, divide by the new power, 3 plus 2 plus 1 is a 3. Please, the integral symbol, is eliminated. plus, that would be 8x, there's a 1 plus 1, you divide by the new power, which is a 2. If you just have a number, please, like I said, give it a letter. But don't forget to put up the arbitrary constant. So what is that going to give you? To be 3x to the power 3 over 3 plus 8x to the power 2 over 2 minus 5x plus c. Please reduce it to its simplest form. 3 there, 1, 3 there, 1. So it will be x to the power 3 plus 2 into 8 is 4x raised to the power 2 minus 5x, and that would be plus c. So this is what we have there when you're dealing with a polynomial. So these questions came in the paper 1 ECZ exam. Let's try to look at some other questions that we are looking at in the B part there. Again, they are telling us the same. So it is 6x squared minus 5. You integrate with respect to dx. So how is that going to be? It is 6x squared. You increase plus 1. You divide by the new power. 2 plus 1 is a 3. Minus, if you have a number, just give it a letter. Plus the arbitrary constant. So it will be 6x to the power 3 divided by 3 minus 5x plus c. Remember, 3 can go into 6 2 times, so it will be 2x to the power 3 minus 5x plus the arbitrary constant. So you always put up a constant when they have not given you the upper limit, like in your paper 2. I'll demonstrate in my next videos. You'll be able to see that. The question again may say, they may say integrate the following with respect to x. So integrate. So they have given you to integrate 3x to the power 4 minus 4x raised to that one. So you can put up the integration symbol yourself now. So this whole thing in brackets, because you are integrating, what letter are they using? X, or with respect to x. So that's why we write dx. So it is going to be 3x to the power 4, you add plus 1, you divide by everything by the new power, which is 4 plus 1, so it's a 5, minus, that would be 4x, remember, minus 3 plus 1, divide by the new power, negative 3 plus 1 will give me negative 2 plus the constant, the arbitrary constant. So that is going to be 3x to the power 5 over 5 minus, remember, negative and negative, it will change to positive. 2 into 4 is a 2x. Negative 3 plus 1 will give me negative 2 plus c. If you want, you can also end there, but others might have said 3 over 5 x to the power 5 plus 2 over x to the power 2 plus a c. This would have been dropped down if you remember the rules of indices. All right, let's look at the last one there. Let's try to integrate the last one there that we do have, the B part. That's number 2b. So integrate 3x to the power 3 over 2 minus 5x plus 1 over x to the power 2 with respect to x. So sometimes it's good to actually drop them. You need to pay particular attention when it actually comes to that. So how do we go about that? So for you to go about that one, remember it is 3 over 2. That can be written as x to the power 3. Let me just write it like that, minus 5x. And this one, the one can be dropped, the reciprocal, it will be x minus 2, with respect to x. I was just trying to, drop it nicely so that you're able to see. This is 3 over 2. That's why I've written then x to the power 3. Then at this point, I can now integrate. So how is that going to be? So it is going to be 3 over 2 x, 3 plus 1, that's a 4. You add plus 1, divide by the new power. It's the new power, it's a 4, minus, it's 5 there. Since it's just x, it already has 1, plus an 1 over the new power, which is a 2. And that would be x, negative 2 plus 1. And what's the new power? Negative 2 plus 1 is a negative 1. Please include your c there, as long as they have not given you the upper limit in your paper 1. So now, if you notice, some people get confused. It's like, let me just briefly use my blue marker. You're able to see this expression here. It's like me saying 3 over 2 divided by 4. That's what it simply means. How would that be? or 3 over 4, remember you change to multiplication, so it will be, this is the same as over 1. When you change the multiplication sign, this goes there, this comes there, so it will be 1 over 4. So it will be 3 times 1 will be 3, and 2 times 4 will be 8. So this, when you work it out, it will be 3 over 8. So that's what I wanted you to understand there, because people make mistakes in the exam. So this is going to be 3 over 8, then x to the power 4 minus 5 over 2x to the power 2. Then positive and negative is a negative there, so it will be x then minus 1 plus c. Yeah, that's what we mean. So this is the expression that you have. But if you want here, this one here can actually be written as, you can write it as 1 over, x. That's what I can do. So the whole expression here, I can have 3 over 8x to the power 4 minus 5 over 2x squared. This I can have minus 1 over x plus c. So that's what we mean. So plus c. So that's what you're having there. So that's basically, this idea that we're having there. Well, watch out for my more videos as I, introduce you now to, the upper limits, when they give you limits and they tell you to integrate, and how to find, the equations to the normal and also tangents. Thank you so much for watching. See you in my next video. Please like and subscribe if you want to see more videos.